Good afternoon, Johnson's class.
Good afternoon, Mr.
Today we finished 1.3 exponents and multiplying with numbers that end in 0. Are you guys good with this?
Yeah.
All right, factor. A factor is what? That was pretty terrible. Numbers in a multiplication problem, right?
Yeah.
Every multiplication problem needs to have at least how many factors? 2. You have to have at least 2, right? A power is a number that is written with an... And an exponent is a little tiny number, and the exponent is kind of what? Kind of what? Kind of bossy, like my wife. The base is like the bigger number, right? And so like when you think of, like I described my wife, I described myself. Am I bigger than her?
Yeah.
So I am like the base, she's the exponent, and she is definitely much bossier than I am. Okay. Standard form, that's just the problem or the answer, yes?
Yeah.
But if we take the problem or the answer and we stretch it way out, we call that...
Expanded form.
Nice. All right. We're going to do this right now. Multiplying with numbers ending in 0. So basically, here's the deal. We have a number 9 and we have a number 10, yes?
Yes.
Does the number 10 end in a 0?
Yes.
Ignore it. Let's just multiply the 9 and the 1, yes?
Yes.
What's 9 times 1?
9.
Can we add that 0 on at the end?
Yes.
We have 9 times 1,000 here, yes?
Yes.
Okay. Again, if we multiply just the 9 and the 1, what do we get?
9.
Add on the 3 zeros at the end, what do we get?
9,000.
So 9 times 1,000 is 9,000, right?
Yes.
So basically all we do is we find the numbers that are not 0. So like in 90 times 30, we find the 9 and the 3 because they're not zeros, right?
Yep.
Yes?
Yes.
I need everybody. What's 9 times 3, guys?
27.
And then how many zeros do we have left over in these two numbers?
2.
Do we tack them on at the end?
Yes.
So you just, when multiplying with numbers that end in 0, you multiply the non-zeros, and then you just add on the zeros at the end, yeah? This whole thing is called a what?
Power.
Say what? Say again?
Power.
What is the little tiny number called?
Exponent.
What is the big number called?
Box.
What's the big number called?
Base.
It's called the base, right? Okay. So exponents are kind of like patterns, right? So let's just take this one right here. I have 4 to the power of 2, yeah?
Yep.
The boss is the,
Exponent.
and the base just kind of listens to the exponent, right?
Yeah.
So the exponent is telling the base to multiply itself how many times?
2 times.
So it's 4 times 4 times 4, right?
Yeah.
Okay, on this one, this is the exponent, yes? This is the base, yes?
Yeah.
What is the exponent telling the base to do?
Multiply itself 4 times.
So 4 times 4 times 4 times 4? Yes, Anna? Your eyes up here, Anna? They should be. They're not up here. The eye should be up here. So I don't really care, but 4 times 4 times 4 times 4 is 256, yes?
Yep.
Cool. So if we stretch it out, that's called what form?
Expanded form.
If we just have an answer, that's called,
Standard form.
or if we just have the power, that's also called.
Standard form.
Does everybody understand what the exponent tells the base to do?
Yes.
Okay? 2 times 2 times 2 times 2 times 2 times 2 times 2. How many times did I multiply 2?
7 times.
So that exponent is saying multiply the 2 7 times, right?
Yep. Yes.
This is a word problem, yes, no?
Yes.
Okay, on a word problem, we generally have a strategy, right?
Yeah.
The strategy is to do what first?
Read.
No, the strategy is to read the problem, then you,
Read it.
and then you,
Write it in your own words.
not write it in your own words, you just say it in your own words, right? Okay, and then I'm not going to do the word problem, it's about Ari's bike trip, but you guys can look at it on your own, okay? We good?
Yep.